In this episode, we learn about brake technology at Wilwood Engineering. Banks built, protected by AMSOIL, with support from Roadster Shop and Nitto.
Wilwood Engineering was founded by Bill Wood back in 1977, and as a young racing enthusiast, Bill cut his teeth at Earhart brakes. The first calipers that Bill ever made were for NASCAR stock car racing, where drivers had been using Earhart brakes or reused factory parts. But as cars began to approach the 200-mile-per-hour mark, the drivers wanted something better. So at the 1977 Riverside 400, Bill talked his way into the pits with his own calipers, meeting several crew chiefs and one Mr. Richard Petty, who took a chance and bolted these unproven new brakes right to his car. Bill went on to supply brakes for sprint cars, midgets, dragsters, street cars, snowmobiles, motorcycles, and hot rods, and by the 1990s, Wilwood was supplying OEM brakes to manufacturers of off-road power sports equipment. When the military caught wind of Wilwood's state-of-the-art engineering, they tapped the company to supply upgraded brakes for the Humvee. And although they're still firmly planted in racing today, Wilwood also supplies brakes for agriculture, roller coasters, wind farms, and just about anything that needs to be decelerated.
Mike,
what's going on, guys? How are you? Thanks for coming over.
Yeah, good to meet you. Oh, so Mike Hamrick. This is Eric Ryder.
Good to meet you,
As
man.
you know, Jay Tillis with Banks. So, man, first off, we have to thank you for all of your help because seriously, Lockjaw would not be 8-lug if it weren't for you.
When you approached us with it, I'm like, this is awesome. Like, this is a build that a lot of people aren't looking at doing. And when I see some of them, sometimes I'm like, oh, I wish they would have done that. So when you said, yeah, we're going to use the Pro Spindle, I'm like,
Mike, this isn't the Pro Spindle, is it?
yes.
'Cause I've seen drawings and pictures, and we looked at lengths, but seeing it in person, I think solidifies why we upgraded.
This is our Pro Spindle. This is based off of a Mustang 2.
Right.
So think about a Mustang 2 or a Pinto, okay? Then think of just a C10, and think of this little tiny bearing, and this little tiny outer bearing. And this, I mean, it's a beautiful hub, don't get me wrong, and it's a forging, so it's made really well, but this is what we were talking about making into an 8-lug too. And that would have put so much load with that 22-inch wheel that's why I was like, look, we need to look at doing something that's going to have a little more bearing and be able to hold that weight. The power you guys are putting in this thing in the transmission, it's an Allison, right?
Yes. Allison
It is heavy,
Yeah.
right? And you're going to have all that loaded out on it like this. With this, although this is made from a net forging, which is kind of crazy, like in the hot rod world, that's why so many people use it, it's super strong. But you're still going to get pin deflection, and that's a bad thing.
Yes, we're going from, this surface area all the way up to, a huge grab.
Yes, to a much bigger grab. So this would be a very similar unit bearing that comes in like a 99 and up Chevy half-ton pickup, which is way closer to the C10 size pickup, right? We're going to go from this, and now we're talking about a much larger bearing. So it's going to be able to take all that weight, and you'll never have a problem with it. As long as we have these pickup points, and Roadster Shop was able to make this spindle work on the chassis, which of course I knew that they could, this is going to be a better representation. In the long run, you're never going to have to think about this part of the build, ever. I know you guys are going to do a lot of testing, probably a lot of dyno runs on this drivetrain, right?
Spirited driving.
You're not going to worry about this stuff. This stuff is just going to be there, So going from this to this, and then finally to that shorter spindle, and it's kind of crazy when Kibbe is telling you like most off-road, it's 20 inches, right?
Spread, yeah.
So this was super out of his box, but it's cool that he looked at it and went, yeah, you know what, this is probably the right way to do it as well.
And bringing in the pre-runner technology into that little package.
Absolutely.
I don't think people really understand, because we've done the last couple episodes talking about this, and I think so many of our audience members they're engine people, and they don't understand how important this is. Some do, some don't. And we've spent a couple episodes talking about this whole process. And we're like, this is obvious to us, but apparently not as obvious to others.
No.
And when you see this comparison, I mean, Eric, you're seeing this. I mean, look at this guy.
Yeah.
There's just no way that this assembly would properly accommodate. Like, look at that.
Right?
Looks wrong.
I ran some numbers on the brakes we're going to put on the truck. We really wanted to make it so that Wilwood could say, hey, those are brakes off of a 2011 to 19 model 2500 Chevy or 3500 fleet side, so single wheel. Okay. So these are the brakes that we do for that. The front calipers have 8.7 square inches of clamping force. So it's a 6-piston, has a 2-inch piston, an 1.75 piston, 1.75 piston. So when you add that up and get the square area, it's 8.7. To give you an idea of how much that is, we have like a little Dynalite caliper here, and that has got 4.8. Right. But what's crazy is that's way less than half the size of this, right? So that thing's really got a lot of bang for its buck, that little caliper. But what we're doing is we're building in a bunch of efficiency because this brake caliper and system is going on a much heavier vehicle that's going to be towing a lot of heavy weight, right? When we come up with the final balance on this car, or the bias, a factory 2500 brake system that we produce is 57% front brake and 43 rear. Now, a lot of like street cars are 70-30-ish, but on trucks, they typically have a payload, so they build a little more rear bias into them, right? Okay. So with what we're doing here, I didn't want to start changing piston sizes and calipers because we actually could have. What we're going to do is we're going to help solve the pedal feel by a 10-to-1 manual brake pedal with master cylinders that are separate so we can give the correct amount of volume and PSI to front and rear to get close to this kind of a bias. Because again, this is also these brake systems are designed for an ABS system. So we also can't be too far off of volume and pressures or else you start having other issues with the ABS system. We don't have that problem. And when we get over the pedals, you're gonna like this because it's gonna look dope.
Mike, this is a 15-inch rotor, right?
It sure is.
Want to grab that wheel we brought?
Oh, yeah.
So here we got a Miata wheel, 15-inch wheel against a 15-inch truck brake.
It's crazy,
That's
right?
absurd. Yeah, 2,000-pound car versus 10,000-pound truck.
Yep.
A lot of stopping force there. Can we get technical, Mike? I'd love to really dive into these brakes and see what they're all about. Because I know two pieces look really cool, but they also serve a purpose as well.
A lot of purpose. Like in a race car, it's really for two reasons. It's you normally have an aluminum hat, so we can discharge a lot of the saturation that we get in this cast iron into the aluminum, and then it helps dissipate the heat easier, right?
Are you guys going 60-61 for?
Yeah, and it's made from a forging as well. So super, super rigid to start with.
Yeah.
The next thing that's a lot of people don't realize why a two-piece is so good with an aluminum hat is when you have a one-piece hat rotor, you're displacing a lot of the temperature that was in that cast iron into the hub assembly, and then that wears out bearings, right?
Yeah, premature wear.
So going to a two-piece, now we're saturating the cast iron, which is discharging it into the aluminum, dissipating the heat easier. It's way better and it's lighter, see? So there's a lot of fundamentals in it.
Crucial weight savings with unsprung and rotational mass. And
absolutely.
It's a huge place to save weight.
Yep. So with this particular setup, we're bolting it together.
So two-piece fixed.
Two-piece fixed. And on this application, fixed is fine.
Yeah.
We could totally get into the floating thing, but floating is so that we have radial mount expansion of the rotor so that it stays parallel with the face of the brake pad.
Right, no warping of the rotor.
Well, and knockback.
Yeah.
That's what we're really working on.
What's knockback?
Knockback is when we would have had an issue with this setup where we would have gotten deflection. Then we have a fixed mount caliper. So hold this for a moment.
Yeah, so we've got fixed and floating rotors and we got fixed and floating calipers.
Yeah.
Right, okay. And in this case, Fixed caliper.
Fixed caliper. So the caliper is mounted to the spindle and it doesn't move, right? It doesn't float. So it's fixed mounted. Well, if you get deflection in the spindle, it pushes the rotor, which then pushes the pad, then it pushes the piston, and it displaces that volume back into the master cylinder. So when you go to depress your pedal again, sometimes you have to pump it to displace that volume again. So there's a lot of ins and outs and where to use floating and where not to use floating. So in this application, we've got 10 bolts that hold and fix this together. But what's nice is we're still getting enough growth on the rotor so that it'll still move just enough, just a little bit. And she'll grow and expand and contract.
How much expansion and contraction do you see? Like a millimeter or?
On this application, you're not going to see a lot. And it's because it's such a big chunk of metal, right? So it'll take a lot of saturation before it really starts to have that issue. But like in a race application, gosh, you'll see 1/8 of an inch growth.
So you're touching on 1,500 degrees under the worst conditions?
Down to like 1,200 degrees. You know, so when we put a brake system on the dyno, about 1,200 is when you'll really start to see some expansion. And what we're trying again with a floating system is that rotor can expand and contract in a linear or parallel to the fixed mount.
Keep it radial.
Yep.
Yeah, and then it's not tied into the one piece here to where, you know, if this is growing, it wants to warp with it, and then if you have the one piece, it's not going to shrink and grow correctly relative to the rest of everything.
You're spot on with that. And I call it paper clipping. You know, a paper clip, you can bend it over, right? And it comes back. Well, it's going to come back. But while it's bending, it's pushing those pistons back. Now, here's the next thing to touch on is, and you brought up fixed and floating calipers. Now, when you've got these big trucks, you've got lots of square area. So the front brake system is close to 8.5 inches, right? That's a lot of volume. So when it's a floating caliper, you've got inboard pistons, and it has to push and pull. So there's a word that I use a lot, and that's called compliance. Compliance is the difference between pushing on this and pushing on this. Mm-hmm. We want less compliance because then it translates to a better pedal feel.
And then another thing here you could see is the two-piece, you really get a good idea of vanes and even, you know, curved and directional vanes here and how it acts as a pump.
Absolutely. So this rotor is called, and by the way, this is 1.5 inches. So it's a 15-inch, 1.5 inches, and then we call it a staggered curved vane. And the reason it's staggered is if you look, every other vane is machined out. And it's not machined out, it's actually done in the casting process.
Is that for heat dissipation?
It helps with heat
surface area.
Surface area. And it's awesome because you're touching on a lot of things that people don't realize with this design is by opening this, we now have more surface area. So when our engineers design this, there's 2 places that we get more surface area. If it's a straight vane, less surface area. Mm-hmm. And it's not this surface area that everybody always thinks of, right? It's this surface area, it's that surface area, it's all inside here, the surface area. So by doing a directional vane, that line is longer. So now we have more heat dissipation.
Yeah, same thing goes with gears. That's why you see curved gears on pinions.
Right.
You have more in contact, more surface area.
Diagonal.
It's a stronger piece.
Sure.
So as far as brake pads go, are you guys usually running metallics?
So everything that we manufacture is going to be based off of semi-metallic. There's not going to be anything that's organic. The particular pad material that we're going to be using in this brake system is a little bit more aggressive than our just regular BP10 brake pad that's designed for the street. This is a little more aggressive.
A little bigger than your Miata pad?
Yeah, maybe you should put all of my brake pads together. It might equal this one.
So a lot of technology inside of just the brake pad, by the way. So it uses a system called the New Cap Retention System, NRS.
Say that again?
New Cap Retention System. And what that is they take a brake pad, backing plate, and it looks like little gouges. and then they press the material onto it. Well, by having a plate that's all one piece without holes, you'll see a lot of brake pads have holes in the backing plate. Well, those are typically where they're glued together. And that's going to be great for a street application, but when you start talking about high temperature, a lot of vibration, you'll start to have problems where the glue will come undone. With the new cap retention system, that won't happen. It stays stuck to the backing plate, and because the backing plate is all one piece, it has a lot more integrity.
What are you using to adhere the material to the backing plate?
This is literally pressed on, and it's done under, I believe, cold. So it's pressed on very, very high pressure onto the little NRS.
So Mike, we touched on pretty much everything going on here. Just how important is everything feeding this? So you got the brake, the master cylinder, the lines. I assume that is just as, if not way more important, it looks like by the expression on your face.
And it is like super important because that's where people usually fail with their brake system. So they believe that this is like the holy grail, like this is what stops it. Well, it's not really. There's a lot of things that would go into deciphering what leverage of a pedal and what bore size master cylinder or cylinders, which is what we're going to do on this truck, is have a balance bar so that we can feed the system properly. When we're looking at a brake pedal assembly, there's a couple things we need to look at. How heavy is it? I mean, that has a lot to do with it. For your Miata, we could use a smaller or less leverage brake pedal, right? Yeah. And it'll probably have smaller calipers on it, so we can tailor everything to that size.
Fit it to each other.
Right?
Yeah.
But on this, it's going to be heavy, and it's going to be using calipers and a brake system that uses a lot of volume. So we need to make sure that we pick everything so that we're going to build pressure easy without wearing a leg out, right? So if you look at this pedal, this is a newer pedal of ours, and we've been using it in a lot of applications that are off-road and truck-based. So you guys ever see King of the Hammers?
Yeah, of course.
Oh, yeah.
A lot of those vehicles, you've got a 17-inch wheel with as much brake as we can put inside that wheel, right? So we're literally shoving a 14-inch rotor with a decent-sized 6-piston caliper in it. Well, we can't use a smaller leverage pedal because when you're stuck in the rocks as well, your leg would get worn out. So we've come up with a 10-to-1 pedal, and you know what leverage is, right?
Oh, yeah.
Leverage is important. And a lot of people don't think about these things. So making sure that we get enough leverage so we don't wear our leg out, then we can tailor the master cylinder bore sizes because we're going to use what's called a balance bar. You know how a balance bar works? No?
No.
Have you ever seen that?
I have, but no, I've never looked into it.
And that could totally be another whole story. But a balance bar helps us balance the front to rear bias in a vehicle, okay? And in some cases, you'll set it up and then you'll never touch it again. That's what your truck's going to be. We're probably going to have to try a couple different bore size master cylinders front and rear until we find the right setup. And here's why. I don't think Wilwood's ever been a part of a creation like this. So, we designed these brakes to go onto a factory 2500, 3500, but never using a non-ABS system with a pedal that's going to be fabricated using the correct bore size masters. A couple things that I looked at. We're going to spec this out. We're going to spec out this master cylinder, which is called our compact short remote. So we can do it remote too. So I'm going to show you guys that we can make the reservoirs remote if we have to.
Just run some stainless line and
How cool.
Stainless line, or if you grab that hose right there, that's what normally comes on our race application. So that would mount here. And then we could use this plastic reservoir, which we use for a lot of racing. Now we have this new race reservoir. So it's made from a forging, it's super lightweight.
Let's billet.
Exactly.
Yeah, I thought for sure that was billet.
Oh
so
my
we machine
Lord.
it. So it turns into a billet because it's a forging that's turned into a billet. Yeah. Using this style of master cylinder, super clean, easy to plumb. Use this new reservoir. I think it'll go with the patina of the vehicle. I think we're going to start off with a 7/8 front and a 1-inch rear. And here's why. A lot of people might say, that seems a little small. Well, keep in mind that the smaller diameter helps us build pressure easier, okay?
Okay.
And we want more front brake than rear brake. So we're gonna put a little bit smaller bore master to the front than we are to the rear, right? So then the output will be higher pressure to the front brakes, lower pressure to the rear brakes. But what does that change? Volume. So now that 7/8 has to stroke even further because it's also going to bigger calipers, more square area, right?
So it's a mixture of the balance rod as well as how you size out the... Okay.
And the length of the arms, or not the arms, but the length, I call them arms because I always give this example. The length of the push rod determines our bias.
Yeah, I mean, it makes sense, but I had no idea how much science went into the bias between front and rear.
It's a lot. It's a lot. So what we're gonna do, and when we first get the truck all set up, we're gonna extend the rod to the front brakes probably 1/4, 3/8 of an inch longer than the rear brakes. Because that front's gonna need to extend longer or travel further to displace more volume to the bigger calipers, but it's gonna build more PSI to make the front stop better than the back, right? So there's a lot going on here, and I think that as you guys get to the build part of the vehicle, you know, it's going to be just like driving it down the street and coming back and going, I might be able to just crawl under there and make some adjustments to the balance bar, and then you're going to go, oh my God, it stops so much better. So a lot of things that are going to come into play after you're at the point of like bleeding the brakes. So that's something about this project where I'm like, I've never really done this, right? So that's why I don't know what bore size master to really do either. And going into it without saying this is exactly what we're gonna do, it gives it a better way for us all to learn from it. So you guys have seen what we make. Do you wanna see how we make it?
In the next episode, we find out how high-performance brakes are manufactured.
Way stronger than a billet and less waste than a billet.
Hi guys, Gale Banks here. I hope you're enjoying the show. If you got any ideas on how we might improve this rust bucket, be sure and put them in the comments below. And don't forget to like and subscribe.